Good morning, Amy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Good, good. So we had been working with this compound angle formula. Are the concepts clear to you?
Yeah, it's really clear. We've discussed sine and cos, and those have been really clear. But in my book, we're also coming across tan. So you did say next lesson we can maybe cover that, if that's
Yes.
all right.
So today we are going to look into the tan of compound angles, a plus b. Let me share the screen with you and we'll begin from there. So can you see my screen?
Yes, I can.
Great. So can you read it?
So compound angle tangent ratio.
Correct. So we'll look into how do we derive the formula of tan a plus b, right? That's the compound, so adding two angles. We have already seen the compound angles formulae for sine and cosine, whether it was a plus b, a minus b, whatever combination. We have these four set of formulae, correct?
Yeah.
Which you are absolutely clear. And what is tan? It is the ratio of sine and cosine, correct?
Right.
So simple as that. So when we want to find the ratio for tan a plus b, we can divide sine a plus b by cosine a plus b, correct? So I've written in the numerator sine a cos b plus cos a sine b, which is expansion for sine a plus b. And in the denominator, we have written cos a cos b minus sine a sine b, which is, which is this one, right? The expansion for cos a plus b. So that gives you tan a plus b. Now we need to simplify, that is to say, write the sine and cosine back in terms of tangents. What should I do? The technique used is that divide each and every term by cos a cos b. You see that? So when you divide each term by cos a cos b, what happens? Well, you can see cos b cancels here. Then in this next line. So when I'm dividing by cos a cos b, that is the statement. We are dividing everything by cos a cos b, correct?
Yeah.
All the four terms. So in that case, what really happens? We can cancel the like terms from numerator and denominator, right? So I'm just canceling the like terms. All this gets canceled. And here we get what? Sine a over cos a is what? Tan a, correct?
Yeah.
And sine b over cos b is
tan b.
In the denominator, we get 1 since cos a cos b cancelled with cos a cos b minus sine a over cos a is tan a and sine b over cos b is tan b. So we get our formula, which is tan a plus b divided by 1 minus tan a tan b. Is that clear to you?
Yes. Yeah.
So with a minus b, I did exactly the same. Perfect. As you know, sine a minus b has a negative sign here, and cos a minus b has a positive sign. Dividing all these four terms by cos a cos b and simplifying, what we get is the formula tan a minus tan b divided by 1 plus tan a tan b, correct?
Yeah.
Simple, just as we did earlier. There you go. So that is a simple derivation for the tangent ratio compound angle formula. Is that okay? So I could write both of them as this. Tan of A plus B equals to sum of tans, right? Plus tan B over 1 minus their product.
Minus tan B.
Correct. In case we have negative here, in that case the signs will change and we get negative positive. So both the formula can be written in this particular form. Is this absolutely clear to you, Amy?
Yeah, very clear.
No problems, right? Now, from here, we can also derive formula for tan 2a. Can you do that for me? How will you find the formula for tan 2a? Tell me.
Do we have to do I was going to do a simultaneous equation just by adding those two.
So what we can do is we can say, well, let b
replace
right?
b by, yeah.
So in that case, what do you get here? We get tan of a plus a,
A.
right? Which becomes 2a, right? Which is equals to tan a.
Plus tan A
Correct.
minus, no, 1 over tan A,
Which is 2 times tan a
over 1 minus tan A squared. Oh, squared
square
A.
a. Is that clear to you? Simple as that. So we
Yeah.
have double angle formula for tangent also. Is that okay?
Oh, right. That's nice and straightforward. Yeah.
So there you go. So that is the proof which we have done. From double angle, we can relate to half angle also. Look here. If instead of this, I write tan of theta, that means I'm writing 2a as equal to theta, right? So in that case, a is theta by 2, right?
Right.
So this will becomes 2 times tan theta by 2 divided by 1 minus tan squared theta by 2. Do you see that? We have converted it into an half angle formula also.
So can you do that with the cos and the sine as well?
Yeah, same.
Okay.
So you
Cool.
remember cos 2 theta as sine 2 theta formula? Let me write down. Cos 2 theta was
Equals
2 cos square theta, for example.
minus 1.
Yeah, right. So we could write this as, let's say, cos of alpha, let us say, right?
Yeah.
So it will be 2 of cos square alpha by 2 minus 1, correct?
Yeah.
Theta by alpha by 2.
Oh, okay.
So you could directly get into, half angle formula. That means if you know what is tan of 30 degrees, you can find tan of 15 degrees also. You get the idea.
Right. Yeah.
Direct,
That's when you said adding. Yeah, adding that.
Yeah. So now, well, here is a proof for you, right? Can you please go through the proof once again? How do we get the double angle formula?
Yeah. So tan A plus B equals tan A plus tan B over 1 minus tan A tan B. And then to get the double angle, you're basically substituting B equal to A.
Okay.
So everywhere you see a B, you just put an A. So that's how we got tan A plus A, which equals tan A plus tan A, which is 2 tan A. And then you've got over 1 minus tan A, then tan A, which is tan squared A.
Perfect. Easy. Simple as that. So you can add this formula to your list of formulae. Now here is the first question for you. Tan of 160 degree minus tan of 100 degrees divided by 1 minus tan 160 tan 100. How much should that be equal to? Can you tell me? How will you do this question?
It will be equal to tan 2 times A, which is 160
minus 100. Because this is tan A minus B formula, right?
Oh, this is not the double angle. Sorry, my bad. Yep.
A minus B formula, correct? So if you apply tan A minus B formula, numerator has got that minus. So that is the corresponding, right? If it is plus, it is plus. And if it is minus, it is minus, right? Signs reverses. So tan 160 is basically tan 160 minus 100, correct? So I could write this as what? Tan of 60 degrees, correct?
But how come it's minus and minus? Because I wrote down.
Right. Oh, sorry. This should be
That's
plus.
what I got misled to think it was the double angle.
Okay.
Yeah.
Sorry for that. That's a typing error. Yes.
Oh, right. Okay.
It should have been plus here. Good job. So that'll be tan of 60 degrees. And to get the tan of 60 degrees, you can always sketch your special triangle, correct?
Right.
60, 90 degrees?
Yeah.
The sides are 1 to square root 3. The answer is square root 3, correct?
Yes.
Perfect. So those are the type of questions which you can very easily do now. Now, can you find the exact value of tan of 75 degrees?
Yes. So you can use the compound formula for tan, A plus B, and you can sub in A is 60, B is 15, and then just sub them in and get.
You don't know the value of 15, so add 30 and 45 to get 75. You get the idea? So when you get tan 30 and tan 45, use your special triangles. You know, the two triangles. The other one is 1, 1 and square root 2, correct?
Oh, yeah. Mm-hmm.
So use these triangles and you can get your solution. Is that clear to you?
Yep, clear.
Perfect. So they are not difficult. So here is the solution of both the questions which we just discussed, right? Of course, I made a typing error here, so let me just correct this part. So the very first one was tan of 160 degrees minus tan of 100 degrees divided by 1 plus tan 160 times tan 100. This is basically equal to this 160 minus 100, tan of 160 minus 100, which is tan of 60 degrees. And if you look into the special triangle, you can see the side opposite to 60 degrees square root 3. And therefore, the tan ratio is square root 3, adjacent side being 1, correct?
Right.
Tan of 75. So 75 is combination of 30 and 45 degrees. So we wrote, instead of 75 degrees, combination of 30 degrees and 45 degrees. When you expand using the formula, you have the terms with tan 30 and tan 45 degrees. We know both the values. Tan of 30, looking from this side, is 1 over square root 3. Tan of 45 is 1. So you do get a value. Now, when you get radical form, it is very important to rationalize the answer. You get the idea? So
Yeah.
that's why we need to do something more, which is rationalization. Right. So I just multiplied by square root 3 in both numerator and denominator. So in that case, we get 1 plus square root 3 in the numerator and square root 3 minus 1 in the denominator, right? And after that, I rationalize. Do you see rationalize? Multiplying by square root 3 plus 1 in both numerator and denominator. That is the conjugate, right?
Yeah.
So yeah, on the numerator side, we get the perfect square, a square plus 2ab plus b square, which is 3 plus 2 square root 3 plus 1. And in the denominator, it is difference of squares. We get square root 3 square minus 1, which is 3 minus 1. And therefore, we could get this result dividing by 2 and simplifying. We get 2 plus square root 3 as the solution. Is that clear to you?
That's a nice solution. Yeah.
Perfect. So with this, I think you got fairly good idea about how to work with the tangent ratios and the compound angles involved, right?
Right. Yeah.
So if you have any questions, you can ask. Can you summarize this? What did we learn today?
Yeah, I can. So we did learn about the sine and cos compound angle and the double angle formulas. So you kind of just derived it just for tan, the same principle applied. We solved it both for tan A plus B and tan A minus B. And as you've shown there, so with all the cancellations, we got to our answer for both of those. And then to use the double angle formula, you're just simply substituting B equal to A, and that's how you get your tan 2A, which we got. And then we just kind of solved it. So we did examples which used those formulas in a practical way, and we got our answers. And also when we did like the tan 75, for example, I know I chose 60 and 15, which obviously you don't know 15, so always remember your special triangles. That's what I learned. I have to keep in mind.
If you have to find tan 15, what will you do?
Tan 30 divided by 2.
You could do that. Good job. And you could also do 45 minus 30. So there are many combinations. Do you see that? So you could use double angle. But see, if you use the double angle formula, then it is slightly difficult because you get a quadratic equation. You get the
I see.
Let's look into double angle formula, right? So the double angle formula is right there for you. So if you want to use double angle formula to find tan of 15, so A will be 15, correct?
Yeah.
And do you see this quadratic equation? So it is not that easy to simplify. Therefore, you should prefer to do add and subtract concept. Is it sum and difference?
Yeah, it's because of the square. Yeah, definitely. Okay. Got it.
Fine. So from your book, if you have some questions based on this, you can have a look at it, and then we can actually take them up, right? Any question on this particular?
All right. Okay. Yeah. Can I just get that up?
Yeah, sure. You can share your screen, then we can solve it, right? So I'm stop sharing my screen.
All right. Okay.
Yeah. You can share your screen there.
Yeah. It'll just take a second. Sorry, my Wi-Fi is a bit unstable. Okay. Can you see this?
Yeah, I can.
Cool. So I don't know if we've you can tell me when to stop. I haven't really looked through it.
That's a good page. So you selected just the right thing. So we can get into these questions one by one very fast. No problems. So for example, this one, right? So they have directly used the formula, which is tan of A plus B, right?
Yeah.
So tan of 45 degrees plus 45 degrees. Is that okay? Which is tan of 90 degrees, correct?
Oh, wait,
and
so
the answer should be 0.
is it plus 15?
Oh, sorry. Is it plus 15? I thought 45 for you. Sorry.
Sorry.
Sorry. So when it is plus 15, then you will do tan of 45 plus 15, correct?
So to find out tan of 15.
No, just add them up. You don't have to do anything in this time.
Oh.
Add them, tan of 60, right? Which is square root of 3. You see how easy it is.
Yeah. Nice. Okay. Should we try I only because it looks really nasty with the pi?
It's radical, right? This is radians, correct? So A minus B formula, because you're checking the numerator, right? A minus B. So it'll be tan of 7 pi by 12 minus pi by 3, correct?
So 6
tan of. So you can take common denominator of 12, 10 pi here, minus 4 pi, correct?
3 pi over 12.
Yeah, tan of 3 pi over 12, which is tan of
a quarter pi.
Pi over 4, right? Pi over 4 is 1. Do you see that?
Oh.
Does it make sense to you? So you should always remember these two triangles, which is 45 degrees, which is pi by, pi by 4. Let me write pi by 4, which is 1 and square root 2. Tan pi by 4 is, as you know, 1. And the other triangle is, let me just make it here. So that is 60 degrees. Or you can say pi by 3. 30 will be pi by 6. So I just mixed this up, right? So 1 to square root 3.
Yeah, I guess it's getting used to the radians. I'm still getting used to it.
Yeah, so you can just switch to radians. Yeah. Important thing is, if you need to find the decimal values, use your calculator properly, right?
Right. Otherwise, you get the wrong answer. Yeah.
Of course. So that is it for that particular question. Let's look into another one. Go back, please.
Oh, sorry.
The same page. Go to tan. So these are cos and sine. Oh, here. Okay, here we have, right? So cos and sine.
There are more pages to come. I just don't know which ones to select. You know best, so I'll just.
I see. So there's one small question here, which is, given that cos A is minus 4 over 5 and A is an obtuse angle. So when they say obtuse angle, that means, you're somewhere in this quadrant, correct?
180.
Yeah, it could be, it is in this quadrant, right? So in this quadrant, make your triangle in this quadrant. Cos value is minus 4 over 5. That means this is 5, this is 4, right?
Yeah.
So of course, this is 3. So that is the value of cos. So you already have a triangle right there. Find the exact value of this, right? So this is angle A. Let me write A, not theta here. Okay. So what is tan A equals to? Tan A will be 3 over 4, right?
Because, opposite over adjacent.
Yeah, and we found that using Pythagorean theorem, or you can say 5 square minus 4 square square root, correct? 3, 4, 5 is a standard right angle triangle. So very easy to get those values. And now, tan of 45 or pi by 4 is 1. So you could always get the answer for this. Basically, you're trying to find tan of pi by 4 plus tan of A divided by 1 minus tan of pi by 4 times tan A, correct? Substitute the values. Tan A is 3 by 4 and pi by 4 is 1, right? Tan of pi by 4 is equal to 1, correct? Substitute and get your answer. Is that clear to you?
Oh, I was just about to do something else. I was going to take the 3/4 and put it where you see A and then just use the calculator, but you have to put it in the actual formula.
Yeah. Expand and then do it.
Expand it. Yeah. Okay.
Right.
So, there's one tan question there.
A minus B, right? This is simple expansion.
I think you just solved a similar one.
Yeah, similar.
Yeah.
Make your triangles. So you have to take care of the cos rule. Do you understand?
Yeah.
So depending on where you are, so you'll get the sign for tan, whether it's positive or negative,
Right.
and then you should be in a position to complete that question without
So
any.
in both of these, because the angle we're getting is positive, we just need to look in the positive quadrants.
Okay, so they have already said that B is obtuse, right? That means we are in quadrant 2, and in quadrant 2, sign is positive. You see that, right? Only
Yeah.
sign is positive, and both tan and cosine are negative, right? So for each value, tan will be
Oh,
negative term, correct?
I
And
see.
7/24,
It's reflex.
A is a reflex angle, so this one is here, right?
So the one in A is acute, the one in S is obtuse, the one in T is reflex.
Yeah,
What's
yeah.
the one in C?
No, there is no C here. A and B are there, only two angles.
No, I know. Just generally with the cast rule, is the one in quadrant where the C is that what's it called?
Quadrant 4, cosine.
Oh no, I mean like so in quadrant like 1, which is the A for all, it's like acute angles. Then it's obtuse
Okay.
angles.
Reflex angle.
Reflex.
Yeah.
Oh, so even cos is reflex.
Yeah. They both are reflex angles. Yes.
Okay. Yeah.
Reflex means more than 180 degrees. Okay.
Yeah. Okay. Just checking.
Yeah. Good question.
So that's acute, obtuse, and reflex.
Good.
Yep. Okay. So that's fine. There's a couple questions here.
So here we'll use half angle formula, right? Without using your calculator, find exact value of these, right? So we need to find the value of tan pi by 8, right? And what do you know? You know tan pi by 4. Is that okay? So if you want to find what tan pi by 8 is, then tan pi by 8 is what? Tan of pi by 4, half of that. Is that okay?
Yeah, but is there no way to use the double angle formula for this?
Yeah. Double angle formula only we have. We are going to use double angle formula. So we know tan of 2 theta is what? Tan of 2 theta is 2 times tan
theta
over 1
minus tan squared theta.
Correct? Now, since you know pi by 4 is twice. So we could write this as tan of 2 times
pi by 4.
Pi by 8, which is pi by 4, right? 2 times pi by 8 is pi by 4, right?
Yeah, but we want pi by 4?
Yeah, we'll calculate. We'll have a quadratic equation, right?
Okay.
2 tan of pi by 8 over 1 minus tan square of pi by 8. You see that? And this is 1. Tan pi by 4 is 1, right? So we get 1 equals to, do you understand? Or let me redo it. Try to understand like this, that half of pi by 4 is equal to pi by 8, correct?
Yeah.
You can also say pi by 4 is basically equals to twice pi by 8, correct? Pi by 4 is twice pi by 8, correct?
Yeah.
So we can use the formula tan of 2 theta equals to 2 times tan of theta divided by 1 minus tan square theta, correct?
Yeah.
We'll place theta as pi by 2, right? So let this theta be equals to pi by 8. Is that okay? So we get tan of 2 times pi by 8 equals to 2 times tan of pi by 8 over 1 minus tan square of pi by 8. Now that is tan of 45, right? Pi by 4, correct? 2 times tan of pi by 8 over 1 minus tan square of pi by 8. Now this is equal to 1, right? Tan of pi by 4. So you can cross multiply. When you cross multiply, you get 1 minus tan square pi by 8 equals to 2 times tan pi by 8. Do you see that? So you get a quadratic equation, bring them all together, right? So we get tan square pi by 8, bring it to the right side, plus 2 times tan of pi by 8 minus 1 equal to 0. Is that clear to you?
And then solve.
Quadratic formula. So tan of pi by 8 is equals to minus of b plus minus b square, which is 2, right?
Yeah, minus
Minus 4
4.
is 4 times 4. This becomes plus
6
4, right? 4
over
is, this is 1 divided by 2 times 8.
2a.
Get this value. So which is minus 2 plus minus. This is 4 plus 4 is 8.
8.
Which is 4 times 2. So you can write 2 square root 2 here.
2 root 2.
Divided by 2. So you get minus 2 minus plus. Let me write plus minus square. I mean, sorry. We'll just divide by 2. Now let's read the question once again. Which value we are trying to find? Tan of pi by 8 we are trying to find, right?
Yeah.
Well, we got the answer for this actually because they only want this is equal to 1. Our question was done right there. Sorry. I was trying to find the value of pi by 8, by the way.
Oh.
Oh, but we solved our question here itself. Do you see that?
Yeah, at the 1.
Because this
I didn't understand why you did like this whole pi by 4 part. Why couldn't we just sub in pi by 8 into pi by 8 in the equation?
No, I could have written this directly as tan of pi by 4, correct? And then the answer is 1. Because this is double angle formula, right?
Oh, you did the quick way.
No, this is what I'm trying to say is I'm trying to find value of tan pi by 8. That was in my mind. I told you last time that you get the quadratic equation and you should know how to solve that quadratic equation.
Right.
It's tricky. So I'm actually now this question is solved. It has got 1 as the answer and it is straightforward.
Yeah, but you were just showing me how to solve the quadratic equation, which could come up in follow-up questions. So yeah, thank you.
Yeah, and find the value of tan pi by 8. This is what I'm trying to tell you. And this is what you get, right? Divided by 2, you get your answer, which is minus 1 plus minus square root 2.
Root 2.
Now look here. Pi by 8 is basically in quadrant 1. So it should be positive, right?
Yeah.
Correct? Therefore, the answer should not be plus and minus. It should be minus 1 plus square root 2, right?
Right.
Since we are in quadrant 1. Is that clear to you?
Oh, right. It's a lot going on if your question was like that, because you have to think about a lot of things, like the cast rule, the quadrants.
So what I solved for you is, we'll just have a fresh page. What I solved for you is find exact value of tan pi by 8. You get the idea.
Yeah.
Which we came up with minus, now I don't remember, but whatever we had, right? With a plus sign here, plus square root 2, correct? I think that was 1 plus, minus 1 plus square root 2. Is it clear? So that was our answer. Is that clear to you? As far as the question goes, when you get 2 times tan pi by 8 over 1 minus tan square pi by 8, you could write this as equals to tan of 2 times pi by 8, right? Which is equals to tan of pi by 4, and which is equal to 1.
Which is 1. Oh, right. Okay. And that's how you do it without a calculator. Yeah.
That is how you calculate this. I mean, without the calculator, find the exact value. But the question is not that simple in the examination, right?
No.
Question is this. How will you do this? Correct?
Yeah.
So that is what I showed you.
Right.
But, well, there are many examples which I think now you can solve. Correct? So don't worry about secant square and all. You know what tan square theta is? 1 plus tan. You know 1 plus tan square theta is secant square theta, right?
I didn't know that. We haven't learned that yet in school. So
Oh, okay. 1 minute. I'll just tell you all this. Very simple, right?
Oh.
Okay. So let's do. Can you not share your screen?
Yeah.
I will work on a blank screen, right? So let me just have whiteboard here.
We've only learned about sine, cos, and tan.
Oh, very simple. Let me just derive all the formulas in 1 second. Let us say this is my triangle ABC, right angle triangle, correct? So, and let's say this angle is theta for us. Is that okay? So what you know is a square plus b square is equal to c square, correct?
Yeah.
If I divide everything by, let us say b square, what do I get? We get a plus a over b whole square
Plus
plus
1.
1 plus c over b whole square, right? What is a over b?
Wait, so sorry. How come it's plus C? Is it equals C over?
C over, yeah, sorry, is equal, right? C over
Okay.
b, right?
Yeah,
So a over b is what? A over b is cot theta, right?
yeah. Wait,
A,
cos.
yeah, a over b is cotangent, right? Cot
Yeah,
square theta plus 1 equals to c over b, which is cosecant square theta. Is that okay? Now let me go with the second derivation. You can copy this. A square plus b square equals to c square. I could divide this by a square, correct? So we get 1 plus b over a is tan theta, right? And c over a is secant square theta. You see that?
A over. Sorry. Do you think you could just quickly explain the cos one again? I lost you for a second.
Which cos one? The first one? Cosecant?
Yeah. Yeah.
Oh, this is cosecant. Cosecant.
Oh. Okay. Wait. Cosecant squared theta equals cosecant squared theta.
Secant. I wrote it wrong. I wrote
No.
it. Wait. Sorry. Let me do it. Neater job. Okay.
Okay.
Uh, let's say the sides are A, B, and C, correct? Let's say this angle is theta and this is 90 degrees. Clear? You know how do we get our standard sine square theta plus cos square theta? Let me start from there itself, right? A square plus B square is equals to C square, right?
Yeah.
Now, if I divide by C square, I mean, A square by C square plus B square by C square equals to C square by C square. What do we get? We get A over C whole square
Yeah.
plus B over C whole square equals to 1. So A over C is cos, right? So we get cos square theta plus sine square theta equals to 1. Is that clear to you? Oops. Oops.
Oh. I didn't know that's how it was derived.
That is how you did it.
Crazy.
Do you see how simple it is?
Yeah.
Now let me do the other one, which is a square plus b square equals to c square. This time I'll divide by b square, right? Last time I divided by c square, right? So
Yeah.
a square by b square plus b square by b square equals to c square by b square. Is it okay?
Yeah.
So what is a over b? Cotangent, cot square theta plus b over b is 1, right? And c over a is equal to c over a is secant cos. So a over b is cot and c over b is cosecant square theta, right? C over b is reciprocal of sine, right?
Yeah. So I don't know that. So
Okay.
what do you mean? What is cot? Is it
Oh,
1
okay.
over tan?
Yes. Let me write down.
I
Cot
only remember
theta
that
is
because
1
you
over
told
tan
me.
theta.
Yeah, I don't actually. Teachers
Okay.
haven't said
So
anything.
cosecant theta is 1 over sine theta. Is it okay?
Oh, okay.
And secant theta is 1 over cos theta.
Yeah, sorry. If I knew this, then it would make more sense. Okay. Yeah.
Right. Perfect. And now let me divide all these things with, let me change the color. So we have now a square plus b square equals to c square. Let me divide everything by a square. Is it okay?
Okay. Yeah.
So 1 plus b over a is tan, right? And c over a is secant. So that is the third formula. So we got three formulas here, right? Do you see that?
Yeah, I see. Oh, so that's it.
Correct. Okay, I'll tell you another way of doing it. Clear screen.
Oh, wait. Oh,
Don't worry. Cos square theta plus sine square theta equals to 1, correct?
yeah.
Let us divide everything by cos square theta. So you get 1 plus
Tan squared theta.
reciprocal of this is secant.
Secant squared theta.
Done, right?
Oh, that was quicker. I like that method. Okay.
This is better. Yeah, this is better. So
wait, so did you get that formula when you divided by a squared in the previous?
Yeah. Same thing. So I could also divide these things by sine square theta, right? Do it on your own. I'm erasing on purpose. I want you to do it on your own. Is that okay? So
Yeah.
cos over sine is reciprocal of tan, which is cot square theta, right? Plus 1. And this is reciprocal of sine, which is cosecant square theta, third formula. So we have already done 1 plus tan square theta equals to secant square theta. So that is formula number 3. And one, of course, you know, cos square theta plus sine square theta is 1. So you can make a note of these and they can easily be derived from one another, right?
Right.
That's it.
Wow. Okay. That's really clear.
Okay.
I never knew that. Thank you, sir.
Perfect. No problem. So I'll stop sharing this screen. You can summarize today's learning and then we can end the class.
All right. Yeah, so today's learning was about the compound angle formula and the double angle formula for tan, because we covered sine and cos in the previous lessons. And we learned how to derive the double angle formula from the tan just by substituting b equal to a, like we did for cos and sine. Then we went through a couple of examples using those formulas, and I kind of had to make sure that I knew the like the special triangles, just so that I can easily work these solutions out without a calculator. And again, always remember that the units should be the same. So when you're working with radians, ensure to change your calculator to the right one. And then we kind of just diverted a little bit because I didn't really know the basic, the cotangent, the reciprocals, of the other ones. So you helped me to prove it either by dividing by like, because the a squared plus b squared equals c squared, so either dividing individually by like a squared, b squared, or c squared, or using the trigonometric identity of sine squared theta plus cos squared theta equals 1, and then dividing like sine squared and cos squared to get the 3.
Either way, you could do it. So these are the secondary ratios, right? The reciprocal of these, or they are called reciprocal ratios. Yes, you have been working so far with primary trigonometric ratios. Now in your year 13, you're going to work with secondary trigonometric ratios.
All right.
Right. So that makes sense. Okay. Try some questions from your book. In case there is any difficulty, do let me know. Okay. So we'll end